So today's topic is motion of charge particle in the presence of constant electric and magnetic fields. If both electric field and magnetic field are present, the motion will be found to be the sum of two motions, the usual circular Larmor gyration plus a drift of the guiding center. If both electric and magnetic field are present, equation of motion of a charged particle can be written as this equation: m into dv upon dt is mass into acceleration, that is force, and this force is equal to q e plus q v cross b. Q is taken common. So in right hand side we have two forces. First one is QE, that is due to electric field E, and second is QV cross B, that is due to magnetic field B. So when both constant electric field E and constant magnetic field B are applied to charged particle of charge Q, its equation of motion can be written by this equation. Now to simplify, we assume that E vector lies in the xz plane, so that E vector equal to Ex I cap plus Ez k cap. Take y component of Ey equal to 0 for simplicity. And magnetic field B vector is along the direction of z axis, so we write B vector as equal to B k cap. So for simplicity we assume B vector is along the direction of z axis, so it is written as B vector equal to B k cap. B is its magnitude, and let electric field E is in xz plane, so it have only x and z components, so we can write E vector as Ex I cap plus Ez k cap. X component is Ex, for this we write I cap, that is unit vector along the direction of x axis, and z component is Ez, with it we write k cap, that represent the direction of z axis. K cap is unit vector along the direction of z axis. So if we assume E vector equal to Exi plus Ezk and B vector equal to B k cap, and substitute these values in this equation of motion, equation of motion is this: m dv upon dt equal to q into E plus v cross b. Divide this equation by m, we get this equation: dv upon dt equal to q upon m into E plus v cross b. We write this equation as equation 24. Now what will be the x component of this equation? On left hand side we get dvx upon dt. Vx is x component of velocity v vector. So for x component we can write this equation as dvx upon dt equal to, and in right hand side we have q upon m Ex for first term. Ex is the x component of E vector, and then we have qb upon m Vy. It is the x component of v cross b. V cross b we can determine as in previous topic by using this determinant. This is the determinant for v cross b. First row is I cap, j cap, k cap. Second row is Vx, Vy, Vz, which are three components of V vector. And in third row, we have 0, 0, B. These are the three components of B vector. X and Y component of B vector are 0, because B vector we assume along Z axis, and B vector is only B k cap. And value of this determinant is this: I cap B Vy minus J cap B Vx. So X component of V cross B vector is B Vy, and its Y component is minus B Vx. We use this result here in the second term, which is Q upon M into V cross B. So X component of this equation becomes dVx upon dt equal to Q upon M Ex plus QB upon M Vy. Similarly, we can write for Y component as dVy upon dt equal to minus QB upon M Vx. And for Z component, we have dVz upon dt equal to Q upon M Ez. These three equations can be determined from this equation by substituting these values of E vector and B vector and solving V vector cross B vector by using determinant. So we write three equations corresponding to X component, Y component and Z components. These equations we write as equations 25, 26, 27. Integrating equation 27 with respect to t, we get this is equation 27, dVz upon dt equal to Q upon M Ez. If we integrate it with respect to t, then integral of left hand side will be equal to Vz, and integral of right hand side is Q upon M Ez t. Ez is constant, Q upon M is constant, integral dt is t, and plus Ez0, it is constant of motion. If we integrate, we write a constant which we put here as Ez0. Ez0 it must be Vz0 in place of Ez0. It must be equal to, correct it, in place of Ez0 write Vz0, and this Vz0 is the value of Vz at t equal to 0. If we put t equal to 0, then first term in right hand side becomes 0 and we have Vz equal to Vz0. So the second term in right hand side, correct it, it is Vz0 in place of Ez0. And the equation is Vz equal to Q by M EZt plus Vz0. Vz0 is constant. It is the velocity, Z component of velocity. 0 represent t equal to 0 time, initial time. So this is expression for Vz. We write it as equation 28. This gives Z component of velocity due to acceleration along the direction of B vector. Transverse components may be written as X component and Y components can be written as dVx upon dt equal to, this is the relation for dVx upon dt, it is equal to Q upon M Ex plus QB upon M Vy. So it is q upon m Ex, and here we write qb upon m as plus minus omega c. qb upon m is plus minus omega c. It is cyclotron frequency. So assume qb upon m as omega c, which is cyclotron frequency of circular motion, and then in first term of right hand side, which is q upon m Ex, we multiplied by b and divide by b, so that we can find a term like qb upon m, which is plus minus omega c. So qb upon m term is present here in second term of right hand side. We write it as equal to plus minus omega c, and in first term of right hand side it is only q upon m, so we multiplied by b and divide by b, so that it become qb upon m Ex upon b plus minus omega c Vy, and qb upon m we write as plus minus omega c. Take plus minus omega c as common, so we have inside the bracket Ex upon b plus Vy. This is equation 29, and similarly for y component we have dVy upon dt equal to, this is the equation for y component, dVy upon dt equal to minus qb upon m Vx. Here also we write qb upon m as equal to plus minus omega c. It is multiplied by minus sign, so this plus minus sign becomes minus plus. We write qb upon m as plus minus omega c, and with it we have Vx. This equation 26, substituting qb upon m as equal to plus minus omega c, we get this equation 30, dVy upon dt equal to minus plus omega c Vx. Differentiating above equations, we have for constant E, Vx double dot, this equation 29 is for Vx dot, dVx upon dt is Vx dot. It is differentiation of velocity, that is acceleration along x-axis. If we differentiate this equation 29 with respect to t, we get Vx double dot. Vx dot is already, that is dVx upon dt, and if we differentiate with respect to t, we get Vx double dot, 2 times differentiation of Vx, equal to plus minus omega c Ex upon b plus Vy Ex is constant, b is constant, so differentiation of this first term in right hand side is 0. Differentiation of Ex upon b is 0, and differentiation of Vy is Vy dot. So in right hand side the differentiation with respect to t gives plus minus omega c Vy dot. Differentiation of Ex upon b is 0 because Ex is constant, b is constant. These are components of electric field and magnetic field. So we get Vx double dot equal to plus minus omega c Vy dot, and value of Vy dot is given by equation 30. This is Vy dot, that is d Vy upon dt, and it is equal to minus plus omega c Vx. So substituting the value of Vy dot from equation 30, we get Vx double dot equal to minus omega c square Vx. Similarly, if we differentiate equation 30, that is d Vy upon dt equal to minus plus omega c Vx, if we differentiate this equation with respect to t, in left hand side we get Vy double dot, and in right hand side we have minus plus omega c Vx dot. Differentiation of Vx is Vx dot, and value of Vx dot is obtained from equation 29, and from this equation 29 we have Vx dot, that is d Vx upon dt, and it is equal to plus minus omega c into Ex upon b plus Vy. Put this value here, we get Vy double dot, that is minus plus omega c Vx dot, and if we put value of Vx dot, we get minus plus omega c, and this is the value of Vx dot, that is plus minus omega c into Ex upon b plus Vy. If we multiply minus plus with plus minus, we get minus sign, and omega c multiplied by omega c, it is omega c square, and we have Ex upon b plus Vy. Vy double dot is 2 times differentiation of Vy with respect to t, that is d2 Vy upon dt square. And we can add here with Vy Ex upon b. We write in place of Vy, we put Vy plus Ex upon b. We can plus this sign, this term Ex upon b, because Ex upon b is constant and its differentiation gives 0. So left hand side is Vy double dot, which we write as d2 Vy upon dt square, and this d2 upon dt square Vy we write in place of Vy as Vy plus Ex upon b. In place of Vy we write Vy plus Ex upon b, because in right hand side we have this type of term Vy plus Ex upon b. In right hand side we have minus omega c square Ex upon b plus Vy. So we make such term in left hand side also. Now we have these two equations, one for Vx double dot, and in right hand side we get a term of Vx. Similarly, the other is 2 time differentiation of Vy plus Ex upon b, and in right hand side we also have this type of term having Vy plus Ex upon b. These two equations 31 and 32, these are equations of simple harmonic motion, and solution of this equation 31, that is Vx double dot equal to minus omega c square Vx. Solution of this equation can be written as Vx equal to V perpendicular e to the power I omega ct, which is solution of simple harmonic motion. And solution of this equation 32, which is for Vy plus Ex upon b, and its solution gives the value of Vy plus Ex upon b as equal to V perpendicular e to the power I omega ct. Why plus minus sign is plus minus I is used here, we will look it after some later. So Vx is V perpendicular e to the power I omega ct. Vy plus Ex upon B, solution of second equation, must give V perpendicular e to the power I omega ct. We have used plus minus sign with it, which gives value of Vy. Bring Ex upon B to right hand side. So Vy equal to plus minus I V perpendicular e to the power I omega ct minus Ex upon B. So we get the values for Vx and Vy. By solving these two equations for Vx double dot and Vy double dot. So in this case we find the Larmor motion superimposed by a drift of the guiding center in the direction of negative y-axis for Ex greater than 0, for positive Ex. If electric field is not present, only magnetic field is present, we obtained circular motion with fixed guiding center x0, y0. But because now electric field is also present, there is x component of E as Ex. So this comes into this equation as Vy equal to first term, then minus Ex upon B. So effect of electric field is in this equation. Y component of velocity Vy is the first term and then minus Ex upon B. So we see that guiding center is drifted towards the direction of negative y-axis, because we have Vy in expression of Vy, we have this term minus Ex upon B. So guiding center that was fixed earlier when there is only magnetic field, guiding center was x0, y0 point, and that was fixed when electric field was not present. And now if electric field is present, we get this term minus Ex upon B for Vy. This means that guiding center is now drifted along the direction of negative y-axis, which is shown in this figure. In this figure, we have three mutually perpendicular axes, x-axis, y-axis and z-axis. Magnetic field, direction of magnetic field B is along the direction of z-axis. Direction of electric field is along xz plane. Its y component is 0. Now motion of positively charged particle, that is ion, is shown in this figure. It is helical path, and now guiding center is moving towards the direction of negative y-axis. Direction of B vector in this diagram is shown by dot. Dot means perpendicular inward direction, perpendicular to the page. For electron, that is negatively charged particle, motion will be same, but if it is clockwise for ion, then it is anti-clockwise for electron. This is the figure. Particle drifts in crossed electric and magnetic fields. Expression for drift velocity of guiding center VGC. Velocity of guiding center, we write it as VGC. GC is for guiding center. Now guiding center is also moving due to presence of electric field. So we want to find the velocity of this guiding center VGC. The term mdv upon dt gives only the circular motion with angular frequency omega c. So omitting this term in equation 24, we get in equation 24, if we put m into dv upon dt equal to 0, that is left hand side equal to 0, we get E plus V cross B equal to 0 or E equal to minus V cross B. Taking the cross product with B vector. If we take cross product with B vector on both sides, left hand side will become E vector cross B vector and right hand side will become minus V cross B cross B. And it is B cross V cross B. Minus sign is omitted and the places of these two vectors are changed. V cross B is put on right side and B vector is put on left side and minus sign is omitted, as A cross B is equal to minus B cross A. Now this B cross V cross B can be written as B square V minus B dot V times B. Here we have used the formula A cross B cross C. A cross B cross C is A dot C times B minus A dot B times C. If we use this formula, we get A dot C times B gives B dot B times V, and B dot B is B square. We get first term B square V. Then second term is minus A dot B times C. A dot B is B dot V and times C means times B vector. Now we write V vector as V perpendicular vector plus V parallel vector. There are two components, parallel and perpendicular components. Then V vector can be written as V perpendicular plus V parallel. In the second term, we write the component of V parallel, and with this V parallel we have B square, and for perpendicular component that vanishes. If we use perpendicular component, then that dot product will be equal to 0. So only parallel component in right hand side, and with V parallel we have B dot B equal to B square. So the two terms are cancelled out, that are B square V parallel, and the remaining term is B square V perpendicular. The transverse components of above equation are VGC vector equal to E cross B upon B square. V perpendicular from this equation comes equal to E cross B upon B square, and it is VE vector. We define this as VE vector, the electric field drift of guiding center. It is the velocity of guiding center due to presence of electric field. So we write it as VE vector, E for electric field. It is due to presence of electric field. So velocity of guiding center is VGC and it is equal to E cross B upon B square, and we write it as VE vector. We define this as VE, the electric field drift of guiding center. Magnitude of this drift is, if we take only magnitude of this velocity VGC, its magnitude will be equal to E upon B. Units of E are volt per meter and units of B are Tesla. Unit of velocity is then meter per second. It is independent of Q, M and V perpendicular.